So now we're going to be going on to the main conservation of energy. You may have known at some point that the conservation of energy states that in a closed system, the energy going into the system is the same as the energy going out. So the energy remains constant in a closed system. Now, a closed system implies that there are no non-conservative forces. We'll get onto what that means in the next video. But in other words, energy cannot be created nor destroyed, but merely transferred from one kind of energy to another. The one we're going to be looking at in specific is the conservation of mechanical energy. It's mostly said the principle of conservation of mechanical energy. That's why I write it as PCME for that long string of words. But essentially, in a closed system, the conservative potential and kinetic energies remain constant. So the potential energy the initial potential energy plus, or rather, the initial gravitational potential energy plus the initial kinetic energy is equal to the final potential energy plus the final kinetic energy. So if you are standing on top of a building, for instance, and you have a stone, and you chuck it straight down with some initial velocity u, and you're at some height h, and it hits the ground at some speed v, you can either use suvat to find the speed that it hits the ground, or you can use the conservation of mechanical energy. Now, the conservation of mechanical energy is slightly, if you're not good with remembering formulae, all the 5 suvat equations, just remembering the initial, or rather even potential energy, gravitational potential energy that is, and kinetic energy, and you put them together, it's much easier to do problems with the conservation of mechanical energy than it is to do suvat if you're not that great at remembering equations.